Okay, we're just going to quickly look at the quadratic formula. So the quadratic formula is part of the topic of factorizing. Okay, so if we want to factorize things, we look for a common factor. First of all, that actually works for everything. What's try to find a common factor, and then after that, we might look at the difference of two squares. Difference of two squares. We might do a standard trinomial. Terrible handwriting. I'll just put this in a little cloud because it looks nicer as well. We might do a difficult trinomial. I'll just say try. But we can also use this equation. We can use the quadratic equation. The quadratic equation holds true for anything. It works for any quadratic in the form ax squared bx plus c. Okay, if it's in that form, the quadratic equation will work. So we could use the quadratic equation for our difficult trinomials, which might be, for example, 2x squared plus 11x, plus 7 or something. The difficult ones, we've obviously got a number that's other than 1 in front of the x squared. So we did this last time where we were trying to find factors that add to 11 and multiply to give us, not multiply to give us 7, multiply to give us 17, which is 14, which is the 2 times 7. So that's our difficult trinomials. So we could use the quadratic equation for that, but it's easier just to solve it as we did before algebraically. Our standard trinomials, something like x squared plus 2x plus 4, where we're looking for factors that add to give us 2 and multiply to give us 4. Yeah, we can do that. Difference of two squares, that's in the form a squared minus b squared, where our answer is going to be a minus b and a plus b. So those are our different types of factorizing, and it all starts with looking for a common factor. So we've gone through these three, and now this is the equation that would always work. You could actually always use it for every single one of these, but it's just more time consuming. Okay. So let's write out our quadratic equation then. And you're given this equation, so there's no need to worry. So it's x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. An equation that is seared into everyone's memory, which never really gets used much after, unless you're doing kind of serious math. So this is the equation, and what is the equation actually working out? Well, it's trying to work out, x, which is the root of our graph. Okay, so if we've got our standard plane, and we've got a graph, say this is our graph here. The roots of the equation is where the graph crosses the x-axis, which would be here and here, and that's what we're working out. We're working out where does this equation cross the x-axis, okay? Which we do successfully when we factorize normally. That's what we're working out. This way we just get an answer at the end. Okay. So let's do an example then. Okay, so let's say that 2x squared plus 11x plus 5 is equal to 0. Now this is in the form ax squared plus bx plus c, okay, because it's going to be x squared, then the x, then the number. So we don't have to rearrange, that's excellent. And then we're just looking for what is a, b, and c. Well, a, b, and c are simply these numbers, aren't they? The numbers in front of the x's and then the coefficient at the end, okay? And then all we're doing is substituting into the equation. Now what I quite like to do is I like to look at this number here, which is called discriminant, okay? And I like to do that first. So I like to say b squared minus 4ac, and that is equal to b squared, so it's going to be 11 squared. Take away 4 times a, which is 2, times c, which is 5. Okay, so it's 121. Take away 8 times 5, which is 40. So that's going to give me 81. Okay. So usually this actually does pop up in the calculator paper quite a lot. So you can you'll see that. You can use your calculator usually for these questions. So don't worry about too much mental math. So you should be able to do these. And then we're going to substitute in for the rest of the equation. Okay, so that's my discriminant. Okay, discriminant. Substitute in for the rest of it. I'm going to say minus b plus or minus the square root of b squared minus 4ac divided by 2a. So minus b is just minus 11. Excellent. And then I'm saying plus or minus the square root of the discriminant, which is 81, divided by 2 times a, so that's 2 times 2. And I'm just going to write 2 times 2 because people always forget this 2 times a, I always forget that. Okay. And then on the next line, we're going to diverge a little bit. Okay, we're going to do two calculations. We're going to say minus 11 plus the square root of 81 divided by 4. And we're going to say minus 11 take away the square root of 81 divided by 4. Okay, so that's what the plus or minus is saying. It means we need to do two steps. Okay, so this will be minus 11 plus the square root of 81, which would be 9. So plus 9 divided by 4, and then minus 11 take away 9 divided by 4. Okay, so minus 11 plus 9, that's going to give us minus 2. Minus 2 divided by 4, and minus 11 minus 9 minus 21 divided by, oh sorry, minus 20, sorry, divided by 4. So this is just minus a half, and this is minus 5. Okay. Okay, I just paused the video there for a wee sec. I wanted just to substitute these numbers back into my original equation, so minus a half and minus 5. So if you substitute them back into the original, you should just find that you do get 0 at the end. So I've just put them back in. I've got 0, so I know I've got the right answer. Okay. The only thing I'll say when you substitute back in is just remember that squaring a negative number gives you a positive. So I just take my equation down here. Okay. So I'll do it with the minus 5. Okay. So it'll be 2 times minus 5 squared plus 11 times minus 5 plus 5 is equal to 0. So that would give me 2 times 25, because minus 5 squared is 25, plus 11 times 55, so that would be negative 55, plus 5 is equal to 0. Okay, this would give me 50. If I add negative 55, I'm taking away 55, and then plus 5. That will give me 0. Okay, 50 plus 5 is 55. Take 55 away, 0. I can do the same for the half. So what does that mean then? Well, it means that the coordinates of where our quadratic rubbish diagrams out at minus a half and at minus 5, that is where our quadratic cuts the x-axis. Okay, and it's as simple as that. Okay, so quick recap. We're looking at factorizing. We're looking at where x is equal to 0, which is where the graph cuts the x-axis. We can do it in different ways. There's different ways. We've got the normal trinomial where we're looking for factors that add to give us 2, multiply to give us this number. The difficult trinomial where we've got a non-1 at the front here. So we're looking for something that adds to this number and multiplies to give us 2 times 7, which would be 14. We can do difference of 2 squares. So if we see we've got an x squared term, and usually that's like a number, isn't it? It's usually, x squared take away 49. It's usually those kind of questions. Yeah, so it would be x plus 7 and x minus 7. It's usually it's usually those for the difference of 2 squares. So if there's no x in it, you're thinking difference of 2 squares. But if the numbers aren't whole and it's difficult to, if it, like for example here, you would say, well, what adds to give me 2 multiplies to give me 4? Can't really do that easily. This is when the quadratic formula comes in handy, because you can use your calculator and you'll always be able to work out the exact value. Okay, so the quadratic formula is given to you. A, B, and C are just the numbers that sit in front of the x squared, the x, and then the number at the end, and then you substitute in. I like to do the discriminant first, which is this number in here. Okay, and then we substitute in, and we split the equation because we've got the plus and minus, so we end up with 2 equations, which is our 2 roots. Okay, we won't always end up with 2 roots, because sometimes we can be plus or minusing. That could be 0 in there. If the discriminant comes to 0, then it will just be, that would be minus 11 plus or minus 0. So these two would work out the same, wouldn't they? So if this number becomes 0, then you've only got 1 root. Okay, And that actually just means that your equation is doing something like this. It just touches the x-axis once. Okay, so if the discriminant is equal to 0, don't panic, that's fine. It just means you've got one root. And if your discriminant is negative, then it means it's got no roots. So it means that we're up here somewhere. We're not crossing the x-axis in the real plane. So if this discriminant number here becomes a negative number, you would just say there are no roots. Okay, but in this case, we've got the classic where the discriminant is a positive number, which means we've got our two roots because we have to do the plus equation and the minus equation. Okay,